Hello everybody, just having a look at some quadratics that I had found online, and yeah, I'll just show you the way that I would solve them. This is fairly straightforward if you know what you're supposed to be doing. So for all of these questions, your answers will be what values of your variable will end up making the equation equal the number that is on the right hand side. Normally you'd want that to be 0, it just makes things a little bit simpler. So the approach that I do, and this is once you've already reached the pattern of ax squared plus bx plus c equals 0, is you look at the c value. So for this first question here, this is where our c value here, and we need to try to look at the factors there and see which factors, so as in which numbers multiplied together, obviously will equal 6, and therefore if we add them or minus them together, will end up getting us our b value. Okay, so quite a simple one. The factors of 6 are 1, 6, 3 and 2, and which ones can we add together to get 5 is plus 3 plus 2. So that is as simple as v plus 3, v plus 2. Obviously don't forget our brackets. So if we did FOIL with that, we would end up getting v squared plus 5v plus 6, FOIL being first, outer, inner, last. First, outer, inner, last. So that should be familiar for everybody. Now with that v plus 3, v plus 2, all you have to do is have obviously the opposite that's happening within that brackets to end up figuring out what will end up equaling 0. So for v plus 3 to equal 0, it has to be v equals minus 3, and for v plus 2 equals 0, it has to be v equals minus 2. Now if we look at the question on the right, the g squared take 3g equals 4, we don't quite have that in the right format just yet, because we normally have it as ax squared plus bx plus c equals 0. So we need to minus 4 from both sides. That way we'll end up getting 0. So g squared take 3g equals, and if we're minusing 4 from both sides, that means it's going to be minus 4 on that side, and it's going to be 0 on the other side. And now we're doing the same again. We look at the factors of 4, 1, 4, and then obviously 2 and 2. Which of these can we manipulate to end up getting minus 3? Or how about if I add 1 and then minus 4? If I add 1 and minus 4, that will obviously get me minus 3. So that's what it will end up being. G plus 1, G take 4 equals 0. If I want to get the left brackets to equal 0, then I need to make it G minus 1. Oh, sorry, G equals minus 1. Minus 1 plus 0 will be 0. So G can equal minus 1. And on the other side, it will be positive 4. 4 minus 4 will equal 0. Okay, let's go down to the next one. Let's see if we can go through this one a little bit faster. Or actually, this one's in a slightly different format, but that's okay. Again, we just got to look at what's common. So there's a W in here and there's a W there. There's no numbers that are common to them. Think of an imaginary 1 at the front there. Doesn't help us at all. So we just got to take the W out because it's common to both. If we do W squared divided by W, we'll get W. If you do 4W divided by W, you will get plus 4. And then for those to equal 0, W can equal 0, because if the W at the front was a 0, that would make everything in the brackets a 0. The other option is to make the stuff in the brackets a 0, which would go minus 4. So minus 4 plus 4 will equal 0. Now if we look at s squared, take 8s plus 12, we're just doing the same as what we've done before. Our factors, I'll do them in green, slightly different colour, because there's a few more factors in here. So we've got 12 and we've got 1, we've got 6 and we've got 2, we've got 3, we've got 4. I believe that's all of them. And how can we get to minus 8? Well, see those ones? Minus 6, minus 2, that gets us to 8. And it's a positive number there, which is what we need, because a minus times a minus, the 6 multiplied by the 2, minus 6 times minus 2, we'll end up getting the positive that we need. So, yeah, just very quickly, again, we know that it's minus 6 and minus 2, so s minus 6, s minus 2, and then obviously the inverse of these numbers will be our answers. And I don't really need that plus sign, but I'll leave it there. Okay, last couple. I'll leave it in green again. So we've got, for the factors, 35 and 1, 7 and 5. I need to get positive 2. So straight away that tells me if I go a positive 7 and a minus 5, then that will be okay. So that's what I'll end up getting. X plus 7, x minus 5. And we'll move this up a little bit. And then obviously the opposite of those will get us our answer. Get rid of that. Minus 7, positive 5. And put a little line there. That last one, r times r plus 2 equals 99. First up we can expand the brackets. So r times r will be r squared. R times 2r will be r times 2 will be 2r. Now I'm going to do 2 steps in one, so I've expanded the brackets, and this will obviously equal 99, but I'm going to do 2 steps in one. I'm going to minus 99 from both sides, so that means on this side it will be 0, and from the left hand side I'll be minusing 99, so minus 99. Now we'll do the factors of 99. So I can say it's 9 and 11, I can say it's 33 and 3, I can say it's 99 and 1. That's all I can really think of at the moment. Okay, we'll find the answer from that. Look at that, the difference between these two is 2, and we needed 2, 9 and 11. So that's what we'll end up using. Which one's going to be the positive one? It's going to be 11, because we're 2 above 0, which means the bigger number will be the one that's positive. So I'll have that in red actually for my, actually blue, sorry. We'll have r plus, wrong way around, r plus 11, r plus 9 equals 0. Oh, I forgot the equals 0 over here as well, sorry about that, and up there. And yeah, that will end up meaning that we've just got to do the opposite of these to get our r values to make the whole thing equal 0. So r equals minus 11, or r equals, and I've got this symbol wrong, minus positive 9. And there we go. That's some fairly basic quadratics. Hopefully it's not too complicated. And yeah, if you've got any questions, just leave it in the comments below. Thank you so much for your time.